Here is a problem with inscribed square inside a circle and something to do with the areas. So again, this is a test your knowledge problem, so I'll give you the problem and with few hints and see if you can solve it. If not, please watch the entire video. But I would suggest try solving it yourself. So stop the video after getting the hints and see if you can solve it. It's very interesting problem, and I think you have solved similar problems if you have watched all the prior videos of geometry and circles. Okay, so the problem is we have a circle, let's say center O, and we have a square inside the circle, and we have one where outside the circle touching at 4 points. What we have been told is that we have got the radius as r. We have to express the two color shaded areas in terms of r. So what is the area of this in terms of r? What is in terms of r? Okay, so here is hint number 1. Let me make some space here. Hint 1. So to find out the shape of this, try to express this in terms of square and circle. So what that means is that the area of this shape is really the area of the circle minus the square, which would give you the area of all these 4 such square, total of 4. So if I divide that area by 4, you will get this one. So this is hint. So, and if you can find out this, you can apply the similar rules to find out the area of this also. So here is hint number 2. So I'm assuming that you have already been able to find out the area of this. If not, so now finding the area of the circle is easy because you are given r. Now to find out the area of inner square, you have to find out the length of the square. So if this is, let's say, L, then if this would be L by 2 and this will be L by 2. So then apply the Pythagorean theorem for the triangle OX, or let's say OAB. So OAB is a right angle triangle, and this is, let me write down, L by 2 square plus L by 2 square equal to R square. So this would lead to L square by 4 plus L square by 4 equals to R square. So this would lead to R square equal to L square by 2. So R L equal to root 2R. So we have expressed the area of one side of a square is in terms of R. So now here is the entire solution. If you can solve with these hints, please go ahead, but otherwise stay on to see the solution. Or if you already solved it, you can compare your solution with mine. So we have found out, we have expressed L in terms of R. So now let's try to find out the radius of, the area of the inner circle. inner square. So inner square is this L square, correct? So area of inner square equal to L square equal to 2r square equal to 2r square. Area of circle, and area of a circle is pi r square. So as you see, pi is 3.14 and this has 3.14 r square versus 2r square. So it shows that circle is a little bigger than the square. So anyway, coming back to finding out this area. So the difference between area of circle and area of square is pi r square minus 2r square. So this would give you all the total of 4 such areas. So that means the area of one of them is this, pi r square minus 2r square by 4. Just to simplify, pi minus 2 by 4 r square. So this is for this. Now, but in the similar way, we can find out the area of this. So let's see, we have again just the bigger circle. Now the bigger circle, bigger square. So let's try to find out the bigger square this side. Let's say this is L1 in terms of R. So we have L1 and this is R. So if you join, so this is R. So then means if you join it all the way, so the diameter becomes 2R, which is L. So if you see, L1 is same as this diameter of a circle. So that means area of, let me write here, area of big square. So L1, let's write L1 equal to 2R. So L1 square equal to 2R square equal to 4R square. So in the similar way, if we have to find out the total of 4 such areas, so we subtract the area of circle minus the area of from the area of the bigger square, which is this. So the area of, so this is 4 of such areas. So then to find out one area, so we just divide it by 4. This would lead to r square minus pi by 4 r square. So if you take r square common, so it will be 1 minus pi by 4. So this is our inner, this area, and this is our r square minus pi by 4, this area. So again, this problem again shows that any time there it be a little bit odd shape involved, try to find out those odd shapes in terms of the areas of known shapes. So you would be able to solve the problem if you follow that simple basic approach.